So sorry, I'm going to repeat myself because I forgot to hit record. When we launch an object into the air, we call it a projectile. They travel in parabolas. I think I said, though, we're ignoring air resistance and the curvature of the Earth. So technically, in real life, projectiles don't travel in perfect parabolas, but in our magic physics world, they do, and we'll be close. It's much easier to break things into horizontal and vertical components. So example 1 says, break the following velocity vector into its vertical and horizontal components. Okay. There would be Vx. There would be Vy, color, 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 color. That 24, Manraj, opposite, adjacent, or hypotenuse. What about Vx? What about Vy? Which trig function define Vx? Cos. Cos 36 equals Vx over 24. So Vx is going to be 24 cos 36, and I get 19.4. Kessler, which trig function is Vy? Sine 36 equals Vy over 24. 24 sine 36. Oh, typo. Why don't I just backspace and edit, Mr. Dewick? Then you don't have the typo. And I get 14.1. There will be a question on your test somewhere where I just say, hey, find the components, the vertical and horizontal components. Yeah.
Sorry, what should I grab? That's the cosine and sine wrong.
Let me pause. So when you're studying, these two columns are pretty good to kind of like, oh, this is stuff I need to know. So horizontally, Vx is constant because Ax is 0. Because Ax is 0, Vx is constant. They imply each other. What that means is d equals Vit plus a half at squared becomes just dx equals Vxt. Yay! Means if you know the time of flight, you can find the horizontal distance, also called the range. But also, if you know the range, you can find time. If they give you the horizontal distance, you can just go dx over Vx, no quadratic, no having to square root. A nice, easy equation to get the t by itself. Vertically, Kiana, Vy is changing, but Ay is a constant. On the Earth, it's negative 9.8 meters per second squared. Other planets, it's different. So dy is going to be Viyt plus a half at squared. At the top of its arc, right there, Vy equals 0. Does that mean V total is 0 right there? Logan, what is V total right there then? So I agree with you, it can't, because if it was 0, it would be stopped. And it's not, it's still moving. What is, at the very, very top for a split second, what is the velocity equal to? No, it can't be 0 because it would be stopped. The vertical velocity is 0, but what is the total velocity equal to? Not 0, because I would be stopped and frozen there. 9.8 is a bad guess. Don't guess acceleration for velocity. Nuh-uh. Yeah? What? All that's left is Vx at the top for that split second. If you want to know the velocity at the top, it's just Vx because Vy is 0, but Vx doesn't change. Good. Also, if you start on the ground and end on the ground, if there's no cliff, then Vy final is negative Vy initial. If you break it into components and you found that your initial vertical velocity was 11.1, your final vertical velocity is negative 11.1. Because what goes up must come down. Finally, If you are beginning from a vertical height from a cliff, the ground is below you, so your final vertical displacement, your dy, will be negative. Your dy will be negative. I had somebody the other day say to me, Mr. Dewick, you said that projectiles, they travel in parabolas, but I've thrown things and they've kind of wobbled. I've spun a basketball that was warped and I could see that it was wobbling. How can you say that they follow parabolas when they wobble? Put your pencils down, look up. So we're going to toss some objects under bright white lights. The first one is a badminton racket. And that does kind of wobble. And that weight on the end of a stick kind of wobbles. That one really wobbles. What I really should say is projectiles don't travel in parabolas. The center of mass of a projectile will follow a parabola. What's the center of mass? Where mathematically you could combine all the mass and represent the object with the dot, where all the mass averages out. So we're going to toss those same objects under black light, but we have the center of mass painted orange. Here's the badminton racket. No wobble. Here's the mass on the end of a stick. No wobble. Now here's that disc. The first view we're going to get is the center of the disc, which is not the center of mass. You'll notice significant wobble. Now we're going to turn it around. This time the orange dot on the other side is where the center of mass is, because there's a weight off to the side. No wobble. So here's the center of the object, that one that was not having a center of mass at the center, and you can see it looks all herky-jerky as it moves across in slow motion. And then when we put the center of mass, when we put the orange dot at the center of mass and make it glow, parabola. All right. Let's get to today's lesson. Projectiles from cliffs at an angle. You know what we're going to spend most of our time finding? You know what we're going to spend most of our time finding? Time. Okay. So if you give me a projectile launched from a cliff at an angle, did I say angle? Okay, I'll break it into components. And then there's actually 3 ways I can do this. I could find the time to the top, where Vy final is 0. Vertically, the vertical velocity is 0. Then, Rachel, I could let Vy initial be 0 and find the time to the bottom, starting at the top, and then add those 2 times together. Meh. I could do it all at once in one fell swoop. Mr. Dewick prefers that one. Or find the time to the top, double it to get the time back to cliff level, let Vy initial be negative and continue on until it hits the ground, and then add all those 3 together. Meh. I'd rather just get it done. So let's look at a cliff at an angle. I like example 1, I like example 1. Example 1 is a nice question. Shay, what's example 1 want me to find? Okay. Is there a cliff? Is there a projectile at an angle? Did I say angle? So I'm going to go components. Okay. I'm going to redraw this a little larger right here. So there's the 50. There's Vx. There's Vy initial. And that is 30 degrees. Color, 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 color. That 50, opposite, adjacent, or hypotenuse? Hypotenuse, you say. What about Vx? What about Vy? Which trig function is Vx going to be? Cos? And Vy is going to be sine. Wait. Put your pencils down, look up. Which trig function was Vy? Which trig function was Vy? Which trig function was Vy? Mr. Duick, will Vy always be sine? If I give you the velocity relative to the horizon, and I will always do that, yes. You can't use that trick for the airplane in a crosswind or the boat crossing a river because I can give you all sorts of different angles. But for projectiles, we typically measure it from the ground up. Mr. Duick, do you have a dumb way that I can remember that Vy is sine? Mr. Duick, do you have a clever way that I can remember that Vy is sine? I got nothing. Hey, Logan, which trig function is Vx? Of course it is. Of course it is. Okay? So Vy is sine. Vx is cos. If you want to use that as a shortcut, go ahead. If you want to derive it every time, that's fine too. But this will work. Alrighty. Now what? I don't know what that means. Solve it. Okay. The answer is 12. Oh, I'll crunch those later. Before I even do that, what was the tool that I said I was going to use for projectiles all the time? Do you remember? I said it was sort of our free body diagram version, but for projectiles, something that we're just going to use. A T-table or a T-chart. So I'm going to go like this. Horizontal, vertical. Who remembers what were the two physics no-brainers that I could write down right away even without reading the question? And now I'll put in Vx, maybe to 5 sig figs because I'm going to use it. So Vx is 50 cos 30, 43.301. Vy initial. Oh, does that work out dead even? 25? Cool. I want to find time. I know two things. That's not enough. I must know something else. Did the question give me anything else? Sorry? What's final velocity? No, it's not 0. Do a belly flop off of your desk onto the cement. It will hurt. And the reason it will hurt is because when you hit the ground, your final velocity is never 0. After you hit the ground, yes, but when you hit the ground, nuh-uh. Spencer.
Is it that it's like the negative head of the cliff to move by it?
There's something from the diagram that we can just plug right in here. Yeah, dy is negative 60. Now, if they had given me this distance, Spencer, that would be a dx, and this question would be way easier because I wouldn't have to solve a quadratic. But for now, which column do I know 3 things in?
Why?
Because I asked you to. Which column do I know 3 things in? Why? Because I asked you. Okay, the vertical column, I'm going to solve for time vertically. Looking for an equation that's got an A, a VI, a D, and a T in it. There is one. D equals VIT plus a half AT squared, vertical, vertical, vertical. Make sure I put my verticals in. A common temptation, kids want to put the 50 in for VI, because isn't that the initial? No, we're never going to use the slanty. It's neither vertical nor horizontal. It can't go into anything. Why is this the toughest of the 3 projectile questions? Because nothing's 0, so I can't get the t by itself. So, what kind of an equation is this? It's quadratic. You know how I know? It's got a squared. It's going to be either quadratic solver or quadratic formula. First thing, I'm going to plug in my numbers. So I get negative 60 equals 25t minus 4.9 t squared. I did half of negative 9.8 in my head. Sorry. What's step 0 for solving a quadratic? Yeah, and I'm going to plus the 4.9 t squared, and I'm going to minus the 25t over. So I'm going to write it as positive 4.9 t squared. Take away 25t minus 60. That equals 0. If you have the quadratic solver, good, go solve. Those of us that don't, t equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Negative b, which is positive 25, plus some of you might be looking at what I wrote, and you might say, Mr. Newick, you made a typo. You left off the negative. I didn't bother squaring negative 25. I said that's the same as positive 25, and I was so lazy I didn't bother putting the negative 25 in brackets with the squared outside, because the negative was going to vanish anyways. And I get 6.881447995, blah, blah, blah. Is that right? Okay. I'm going to carry some extra sig figs, 6.8814, and now I'll go to 3 sig figs in my final answer. You also got a negative root. What was the negative root? Negative 1 point something something? Okay. I had somebody the other day say, Mr. Dewitt, does that negative root mean anything at all? Like in math, we hang on to it. It's, well, don't write this down. This is just for nerd trivia. If instead of going up and right at 50 meters per second at a 30-degree angle, if you went down and left at 50 meters per second at a 30-degree angle, that's how long it would take you going through the ground to hit the ground level. That's how far you would have had to travel from the ground, how much time would have had to elapse if you had traveled from the ground to get to here. So it kind of means something, but meh. Cool. I'm not going to ask you part A. I'll probably ask you part B. Liz, what's part B? I didn't give you as much room. That must suggest that maybe we can get there a little quicker. Range, horizontal or vertical? dx equals question mark. What was Vx? It was 43.301. Wow, I got the yawns. Got to wake up. T, we just found 6.88. A is 0. So you're correct. Yeah, I can just go dx equals vxt, 43.301. I'm going to write 6.88, but I'm using my answer button because that's what I happen to have stored here. And I get 297.9, you know what, 298 meters. What else could I ask? C. Deegan, what's C want me to find? Isn't that 6.88 seconds? Oh no, that's time to go to the top, come back down, and go all the way back down and hit the grid. Okay, so I know my answer is going to be less than 6.88, just in case I make a calculator mistake. All righty. Deegan, T equals question mark. Deegan, time to reach the what? Does the word top suggest to you vertical or horizontal, or can't you tell? I think vertical. So let's list my vertical data. I know that AY was negative 9.8. VY initial started out at 25. Was it 25? Yeah. Can I use a D of negative 60? Because that's not at the top, that's at the bottom. Very bottom of the cliff. Well, that's only two things. I need three things to find the fourth. What do I know? What's VF? Oh, at the top, VF is 0. That I'll agree with. And I got to be fussy, though. VY vertical is 0. VF is still not 0 at the top because it's booking along sideways. But VY final is 0. Okay, Deegan, I'm looking for an equation. It's got a T and A, a VI, and a VF in it. There is one. Get the T by itself, please. I'll give you a hint. T equals. Beauty. T equals VF minus VI all over A. By the way, you can see how people might panic if they couldn't spot that. If they couldn't see, oh, VY final is 0. They might put in the slanty value. I mean, hopefully they're not going to put in 9.8 for a velocity ever. But then, you know, grasping at straws. Don't do that. Relax. We can do this. Change colors, Mr. Duke. 0 minus 25 all over negative 9.8. 2 point something, I think. Did you all get 2.55? And since that's the final answer, I'll round it to 3 sig figs. I'm definitely asking A and B on your test. Probably asking part C. Probably. A pretty tough question is part D. If I asked this, I would make it a multiple choice question, so it only tweaked you for 1 mark. Kessler, what does D want me to find? What is the impact velocity not equal to? Not equal to 0. Okay? Got me? Okay. Okay. How the heck can I find this? I'm going to DULP. What does DULP stand for? I'm going to draw the impact velocity. Don't write this down. Look up. The impact velocity looks like that. Don't write it down just yet. It might be a little steeper, Or it could be shallow, or I don't have enough calculations yet to be sure yay or nay. But I'm going to kind of draw a generic one and say, okay, that's impact. Draw that. And let's call it V imp. Hey, do you know what it's hitting the ground at? An angle. Everybody? I'm going to break this into components. And I'm going to continue with my do horizontal then vertical, because then I can use my silly side and Y trick. There's Vx. There's Vy. Ooh, this Vy, not initial. You know which Vy this one here is? It's got to be final. Oh, I know one of these. I know Vx. What is Vx? 43.301? Well, that's cool. You know what? If I know Vy final, then it's just Pythagoras and trig. And I'm good. Do I know Vy final? How fast it's traveling vertically when it hits the ground? Do I? No. Fine. Vertical final velocity equals question mark. Oh. Do I know Vy initial? I don't know why I flipped the F and the Y around. Not that it's wrong, but okay. Vy initial was, sorry, what? 25. Still works. AY was what? Negative 9.8. I need three things to find the fourth. What else do I know? I could use a dy of negative 60. I think it's going to be easier if I use a time of 2.55? 6 point, the total flight time. Okay? So T is going to be, and that's why I carried some extra sig figs. I figured I was going to come back to it and use it. 6.8814. Looking for an equation that's got a VF, a VI, and a T in it. There is one. Oh, and the VOI is by itself. By the way, when we impact the ground vertically, what direction are we traveling? So what kind of an answer am I expecting here? I won't freak out, I'll relax. Oh. 6.8814. Plus negative 9.8 times. Typo. Come on, keyboard. Does that look right? Do you get negative 42.4? How about negative 42.438? Now what? Well, I can stick this here. Mr. Deck, shouldn't that be negative 42.43? The negative is contained in the down arrow. That's negative. I wouldn't take marks off if you put the negative on there, but it's kind of redundant. Alrighty. On your own, find the impact velocity, magnitude, and direction. Do it. Let's try that again. Dope. Do you get 60.6 as your magnitude? Where's theta going to go? Top left or bottom right? Top left. Color, 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 color. How can I find the direction? Well, Vy, opposite adjacent or hypotenuse. Opposite. Vx, with trig function. Sorry, I wrote x, adjacent. Tan theta equals 42.438 divided by shift tan 42.43. Let's try that again. 42.438 divided by 43.301. Close off the bottom. I get 44.4 degrees, which I kind of suspected ahead of time because my two leg lengths were really similar. 42.4 and 43.31. You know what? They're close enough. I figured I'm going to get an angle around 45 degrees because it's isosceles. It'll be, 46 or 44 or something like that. So here it is, 44.4 degrees. Oh, we got a problem. I can't write north of, well, in this case, I can't write south of east because that, not north. So how do we write this when it's a side view? We would say at, what was the angle, Mr. Duick? 44.4 degrees below the horizontal. If it was on its way up, it would be above the horizontal. That's a pretty tough question. Let's do another one. What does example 2 want me to find? Is there a cliff? Are we launched at an angle? Okay. I'm going to do my t-table. That's horizontal, that's vertical. Logan, what are the two things I can write? How can I calculate Vy? More specific. Vy initial equals, what would I crunch? Anyone? It's going to be, yeah, you're right. 35 sine 20. So Vy initial (35 sine 20). Is that right, Mr. Duick? Yep. I get 11.9707. Which trig function is Vx? Of course it is. $32.889. I know two things in each column. There must be something else. So I can find time. How am I going to do that? Well, okay. I guess it's going to be negative 20 plus or minus, no, Mr. Duke, we're still plugging it in, equals VI 11.971 T plus a half A instead of a half A, Mr. Duick. How about negative 4.9 T squared? What kind of an equation is this? How do I solve a quadratic? Before I do the quadratic formula, what was step 0? So I'm going to rewrite this as positive 4.9 T squared minus 11.971 T minus 20 equals 0. Try that, see what you get. Alrighty, it's going to be T equals positive 11.971 plus or minus the square root of negative 11.971 squared minus 4 times A times C all over 9.8. So Corella, here's how I would type this. Ready? I would open up a bracket. I would type 11.971 plus square root, open up a bracket. I'm going to ignore the negative. I wrote it, but I'm not going to enter that negative because I know it's going to vanish when I square it anyways. So I'm just going to type positive 11.971 squared. And then I'm going to go minus 4 times 4.9 times button negative 20. And then, not hitting equals yet, have you already hit equals, or?
Yeah, I'm doing
Oh, you're doing your own? Okay. Then I would go close off the square root, close off the top, divided by 9.8. Oh, I got a typo here. Is it 3.58? It is? I'm right? 3.5824? Okay, I don't have a typo here.
Okay.
And a negative root that I'm going to ignore. Did that work?
Yeah.
This is what they wanted me to find. But you know, you spend most. You know what? You spend most of your time finding. Now there are sometimes they'll give you the time. The question's going to fall apart because now you've got something that can go in both columns. The question's going to fall apart. You'll have lots of options. I want to find the range. I want to find dx. Well, dx is vxt. What happened to the plus a half at squared? What was vx? I have no idea. 32.889 times 3.5824, but you know I'm going to use my answer button. If I really wanted to be hyper accurate, instead of 32.889, I could actually go 35 cos 20 close bracket times answer button. Then I haven't done any rounding off along the way. If you want to, you can. Anyways, y'all get 118 meters, 117.8 probably. 118 meters. It's a lot of work for one question. Yep. I would probably make this worth about 7 marks. Yeah. Quick look of money. Did I get to example 3 last time, Mr. Dewick? I can't remember. Did I start example 3? I did. Okay, we did 3A, but not 3B. Folks, try 3A on your own. It does say DULP. I would draw a little picture. So a projectile was launched from a cliff. Here's my cliff. 45 meters high. Angle of 64 degrees. Yoink. 36 meters per second. 64 degrees. I'm going to do the rest of this question on my own quietly. We're just going to do part A, and then we're going to hit pause. So see if you can get this on your own. Quadratic. bracket. That's totally wrong. What did I do wonky here? I think I know what I did. No. 32.357. Negative b plus or minus the square root of b squared minus 4 times a times c. Oh, I opened up a double bracket. There's my problem. Those of you with the solver, what'd you get for t? 783377. Okay. I had a typo. Haven't done that for a while. 7.7834. 7.7834. If you can get this, that's getting perfect on a written question, 7 marks out of 7 marks. But you can see there's lots of room to make mistakes. Okay. I'm going to pause here, but for now, if you want to get a head start on the homework, you can certainly do number 1, probably on a separate piece of paper. You can skip 2. You can try number 3. You can skip 4. You can skip 5. But you can try number 6, 7, and 8. I'll assign more, but if you want to start, you can also technically, because I'm not doing anything new tomorrow, I'm just going to be looking at tougher examples, you can technically do every question on the ultimate review, that big thick package. You can start whittling away at that. If you could get out your smartphone, please.